In this video, we are going to see about phase shift keying. Already in the last videos, we have seen about ASK and FSK. Here we are going to see about PSK. As the first case, similar to FSK, here also we can consider for the binary and for the multi-level. For the binary means only we are considering two pace changes. So one bit is denoted by one signal. In phase shift keying, similar to FSK, in FSK, two binary data, zeros and ones, are represented by two different frequencies. Here, two different paces represent binary data, zeros and ones. So pace of the Harrier signal is shifted to represent data. In binary PSK, two paces represent two binary digits, zeros and ones. If you see this picture, zeros are represented by this pace, minus 108G, and ones are represented by the normal pace. And similar format is maintained for every zeros, and another format is maintained for every ones. In this picture, you can clearly able to see for the zeros, phase is 0, and for the 1, phase is 180. For the phase is represented by 0, that means no phase change. And for the 1, it's 180 phase change. Here, two different phases. That means one bit is represented by one signal. So here, bit rate is equal to baud rate. 5 bits are transmitted and 5 bauds are transmitted. If one signal represents 2 bits, then bit rate will be double when compared to baud rate. But in this case, here we are speaking about binary PSK. So here, one signal is represent 1 bit. So here bit rate is equal to baud rate. In BPSK, when we see the formula here, for the binary one, that is equal to A cos 2 pi FCT. In FSK, we have used a different frequency. That's why we use different F for the frequency. But here we are simply using the Harrier frequency as the ASK. So no change in frequency. And for the binary zeros, there's a phase change by 180 degrees. That's why we are adding pi. Pi is 180 degrees. So that is equal to flipping the sine wave. Similar to multiplying by -1. So simply we can say binary 1 by A cos 2 pi FCT and binary 0 by - A cos 2 pi FCT. Because 1 signal is represented 1 bit, so 1 bit is represented 1 signal. And for the 2 binary zeros, that is equal to 2 bits. Similar to multiplying by -1. So simply we can say binary 1 by A cos 2 pi FCT and binary 0 by - A cos 2 pi FCT. Because It's similar to multiplying by -1. We are flipping this by this. Here you can find the formula. And when you see about differential phase shift keying, as I have explained in digital data to digital signal conversion, differential technique is the technique represented by the transformation of signals in ones. Here also, for the zeros, there is no change in the pace. But for the ones, paces will be alternated. Alternative form of two-level Psk is called as differential Psk, also denoted by dPsk. Binary 0 maintain the same pace as the previous signal, but binary 1 represented by opposite pace to the preceding one. Here for the 0, you wouldn't find any change, but for the binary 1, pace will be changed, and for the next binary 1, again pace will be alternated. So here paces are alternated for the ones. For the 0, no change in the pace, and for the 1, again pace is alternated. And when you see about 4-level Psk, here one signal is represented by 2 bits. So in BPSK, we have used the phase shift of 180 degrees because we need only 2 kinds of phases. But here we need 4 pace levels. So we are shifting by pi by 2, that is 90 degrees. We are going to use 4 different combinations because one signal is representing 2 bits. So 2 to the power of L, that is 2 to the power of 2. Here 4 combinations are possible. So to represent 4 different combinations, we need 4 paces. So we are shifting each by pi by 2. So first is represented by pi by 4, and for the next 3 pi by 4, and for the next minus 3 pi by 4, and for the next minus pi by 4. And this 4-level Psk also called as QPSK. Each signal element represents 2 bits rather than 1. In this example, you can clearly see that is 0, 0, 0 shift, 0 pace, and for the node 1, 90 degrees, that is pi by 2, 1 node, that is pi by 2, 1, 1, 270. This is 90 degree pace, and this is 180 degree. Here also same 180 degree pace. And for the 1, 1, 270, And for the 0, 0, their phase is 0. We can see the difference between QPSK and OQPSK in the next video.